Did you ever hear of the Gegenschein? No, you've never heard of that. The Gegenschein. Did you ever hear of the zodiacal light? Maybe, maybe not. But let me just explain to you what I was doing where I discovered the Gegenschein. I was looking for some type of evidence for some kind of anti-solar illumination zone opposite the sun within the celestial sphere, because if you understand anything about how I explained to you the concave Earth, is that sunlight is wrapping around and converging at the other side. I can show you an illustration of that. This one that I pulled before. The sun at the top here is emanating the light and it is converging at the other side. Very similar to like if you look at a glass of water in the sunlight and you will see the caustic lines. They will converge the opposite side of the illumination. And that's what's happening. Initially I was researching this to find out, or to show you, to illustrate to you how the sun receives illumination. Now, I said from both sides in the previous video, but this is just a cross section. So it's more than just both sides. It's really every side, every angle that the sun is wrapping around. It's illuminating the moon. And so that's why we don't see the graduated shading of the moon. The front side is spherical. It's a half sphere, but we would normally see graduating shading on the moon, but we don't really see that, do we? And you look at a full moon, it's completely illuminated. It's flooded with light. And so that is why that is happening. And I was going to illustrate that. I was going to animate that. I did animate that. Let me just start this rendering here. But these contour lines are showing how the light is converging at this little convergence point. And I didn't even know they had a name for this. They call it the Gegenschein. Now the Gegenschein is very critical for you to understand why a lunar eclipse cannot work in a heliocentric model or a flat model either, but because the Gegenschein, it is a faint patch of light directly opposite the sun, the anti-solar point of the sun. They call it the Lagrangian point number 2. I can show you that over here. Let me get me out of the way here. The Lagrangian point number 2 here. See, this point here is opposite. This is a heliocentric model, of course, but here's the Earth. Now, think about this. Where do lunar eclipses happen? They happen at this Lagrangian point number 2. They happen exactly opposite, in a heliocentric model, they happen exactly opposite the sun, with the moon, with the Earth directly between the sun and the moon. You cannot, ladies and gentlemen, let me reiterate this for you. You cannot have a lunar eclipse in front of the Gegenschein in a heliocentric model. They are mutually exclusive. The moon cannot be covered in Earth's shadow at a point where there is illumination. It's that simple. Do you understand what I'm saying? This Gegenschein point is a bright spot, and that's where the lunar eclipse supposedly happens. There's an image in Photoshop of the Gegenschein. Now they will say it's oval in shape, but what I did is I boosted up the curves. Normally it looks like this, kind of murky. But I boosted up the curves because I wanted to see. I didn't think it was oval, and it's not. It's circular. You can see a circular illumination. Yes, you have this banding effect. And I believe that's happening because of the magnetic field of the sun. For some reason, the sun's light is projecting it like that. But in the center, it's still circular. Okay? So this circular area, if you go back to my illustration here, this is a cross-section top-down. You can imagine this shape here of an apple. It's like an apple, basically, okay? So when the moon is in the apple, you know, the waxing, the first quarter, the waxing gibbous, the waning gibbous, the third quarter, when even the full moon, it's still in the apple. When it leaves the apple, when it goes outside the apple, at the little butt of the apple, it doesn't get illuminated because it's not in this area of light, okay? Let me show you in 3D what I'm talking about here, okay? Here's a wireframe mode here. Okay, this is the moon. Remember I told you it's a half sphere. And so, a little bit hard to tell here with this wireframe, but here if I turn like that, you see how it's sticking itself out of the apple? And that's where it does not have the illumination, okay? Inside the apple, it's lit. Outside, it's not. And so here's the Gegenschein right here. This is illuminating. It's a convergent point where the light converges, okay? I'm going to go back and I could show you how, this is a previous video I made, how lunar eclipses happen, okay? Here's the Gegenschein. I called it the darkness funnel. I didn't know it had a name for it, but it actually does. And so when the moon goes through, when it leaves the apple and sticks out in front of the Gegenschein, it's going to be darker. It's going to be eclipsed. We'll go to the April 4th eclipse here. It's coming up here. Okay. Now, going back to what I said before, this point destroys heliocentrism. Type error. Some astronomers deny it even being there, but there's overwhelming, undeniable evidence. Okay? Undeniable evidence. Let me show you some research here with the Gegenschein. Another mysterious phenomenon associated with the zodiacal light is known as, by its German appellation, the Gegenschein. It is said that in that point of the heavens directly opposite the sun, there is an elliptical patch of light. Now, I just told you I don't think it's elliptical. I think it's circular. I showed you how when you boost up the curves, it's circular. A few degrees in extent of such extreme faintness that it can be seen only by the most sensitive eyes under the best conditions and through the clearest atmosphere. This phenomenon seems so difficult to account for that its existence is sometimes doubted. Now, why do you think people would doubt that? Would doubt its existence? You know why, don't you? Because you cannot have a lunar eclipse in a heliocentric model. That's why they doubt its existence. Yet, the testimony is in its favor, is difficult to set aside. And look at this Wikipedia page on the Gegenschein. Look how weak, look how anemic it is. This is all they talk, this is all they have. If that is not a sign, if that is not indicative that they don't want people to know about the Gegenschein because it destroys a lunar eclipse in a heliocentric model, then I don't know what is. Okay, this is all they say. But they have to admit that it's anti-solar. Gegenschein is German for countershine, a faint brightening of the night sky in the region of the anti-solar point. Gegenschein, ladies and gentlemen. Now, the only way it works is within a concave Earth when the moon, like I said before, is leaving the apple zone of illumination. Okay? The moon is out here like that. It cannot be lit anymore because it's outside the zone. Okay? It's the Gegenschein is like an inverted nipple. Okay? It's so for the most part, if you go from a top-down view here, for the most part, the moon stays within the apple. It only leaves the apple when it goes through the inverted nipple of the Gegenschein. It's hard to say that. But that's what's happening. Now, I also talked before about, I believe that the light that's emanating from the sun is vortexual, and so this Gegenschein, this darkness funnel, it actually will fluctuate north and south. That's why we only get lunar eclipses during the equinoxes, during early April or late September. And let's go back here in After Effects here and play with the moon here. So you take this moon, oops, 1 second here, my arrow, and you can move it around. See, like when it's not orange like that, it's inside the apple of illumination. When I bring it out like that, it leaves the apple zone of illumination, and it goes in front of the Gegenschein. Okay, I believe it's orange like that because of the glass sky, because red is the least amount of refraction when light goes through glass, and just the incident angle involved like that. I believe that's why the moon turns red like that. But that's why the lunar eclipse, now a lot of people, initially when they try to refute concave Earth, they will say, well, how do you explain lunar eclipses? Well, now we can turn that around, concavers. How do you explain the Gegenschein? How can the moon be eclipsed right in the exact area where there is illumination? I'm sure you got an answer for that. Maybe, what is your answer? You got to pull something out of your ass, don't you? Concave Earth is reality. You understand it? You understand how much you've been lied to, ladies and gentlemen? We'll talk about this on our session show on Friday night. This is a slam dunk for Concave Earth. Join the revolution. Talk to you later.